So let's solve this problem. Option A is the value of 4 times of 2 times cos cube of pi by 7 minus cos square of pi by 7 minus cos of pi by 7 is what? Option B is if a plus b plus c is pi and cos of a is equal to cos b times cos c, then tan b times tan c has a value equal to what? Option C is 4 times of cos 20 degree plus 8 times sin 70 degree sin 50 degree times sin 10 degree upon sin square 80 degree is equal to what? And option D is the maximum value of 12 sin theta minus 9 sin square theta is equal to what? सारे पार्ट्स है तो मैं हर एक पार्ट का इंडिविजुअली सॉल्व करूंगा और उनके अंदर जो की कंसेप्ट्स होंगे उन्हें मैं स्टार्टिंग में ही लिस्ट कर दूंगा. सो ऑप्शन ए के अंदर हमें पूछा गया है कि द वैल्यू ऑफ मॉड्यूलस ऑफ 4 टाइम्स ऑफ 2 sin cube of pi by 7 cos cube of pi by 7 minus cos square of pi by 7 minus cos of pi by 7 is equal to what? So the key concept that I'm going to use over here is trigonometric identities, and the identities that I'm going to use over here is cos of 3 theta is equal to 4 cos cube theta minus 3 cos theta. Second identity that I'm going to use over here is cos of 2 theta is equal to 2 times cos square theta minus 1. Third I'm going to use is cos of a plus cos of b is equal to twice of cos of a plus b by 2 times cos of a minus b upon 2. Similarly, cos of a minus cos of b is equal to twice of sine of b plus a upon 2 times sine of b minus a upon identities related to angles that I'm going to use, that I have to use over here is cos of theta is equal to minus cos of pi minus theta. Theta should be in radian. Sine of theta is equal to sine of pi minus theta. Using these many key concepts, I'm going to be solving this problem A. Equation 4 times of 2 cos cube pi upon 7 minus cos square pi by 7 minus cos of pi upon 7 can be rewritten as twice of 2 rather 4 cos cube pi upon 7 minus 3 times cos of pi upon 7 plus cos of pi by 7 minus 2 times cos square of pi upon 7. The first two terms over here will give me cos of 3 pi by 7. This is cos of 3 pi upon 7 minus plus cos of pi upon 7, and the last term is minus 2 cos square pi by 7. I'll rewrite this as minus of 2 times cos square of pi by 7 minus 1 minus 1. This would be equal to twice of cos of 3 pi upon 7 plus cos of pi upon 7 minus cos of 2 pi upon 7 minus 1. Now I'm going to make a slight change to this cos of 3 pi by 7. And I'm going to write this cos of 3 pi by 7. Cos of 3 pi by 7 would be equal to minus cos of pi minus 3 pi by 7 is 4 pi by 7. And replacing this cos of 3 pi by 7 by minus cos of 4 pi by 7, the above equation will become 2 times cos of pi upon 7 minus cos of 4 pi by 7 plus cos of 2 pi by 7 minus 1. This is basically, I'll use the identity over here of cos of a plus cos of b equal to cos of a plus b upon 2 times cos of a minus b upon 2 twice. So this would become 2 times cos of pi upon 7 minus 2 times cos of 4 pi plus 2 pi upon 7 is 6 pi, and upon 2 would be 3 pi by 7 times cos of pi upon 7 this minus 1. So this would be 2 times cos of pi upon 7 times 1 minus 2 times cos of 3 pi upon 7 minus 1. This was basically twice of cos of pi by 7 times 1 minus 2 times cos of 3 pi by 7 upon sine of 3 pi by 7 times sine of 3 pi by 7 minus 1. Simplifying this, we obtain cos of pi upon 7 times sine of 3 pi by 7 minus 2 times cos of 3 pi by 7 times sine of 3 pi by 7 would be sine of 6 pi by 7, sine of 6 pi upon 7 upon sine of 3 pi upon 7 minus 1. Now, sine of 6 pi by 7 can be rewritten using the formula that sine of theta is equal to sine of pi minus theta. Hence, this equation would be cos of pi upon 7 times sine of 3 pi by 7 minus sine of pi by 7 minus 1 whole upon sine of 3 pi by 7, which would be equal to 2 times cos of pi by 7 would remain outside, and I'll use the formula of sine A minus sine B is equal to 2 times of sine of A minus B upon 2. I'll use the formula sine A minus sine B is equal to twice of sine of A minus B upon 2 times cos of A plus B upon 2, which is 2 times cos of pi by 7 times. This would become 2 times sine of pi by 7 times cos of 2 pi by 7 upon sine of 3 pi by 7 minus 1, sorry, rather minus 2, which is basically I'll send this cos of pi by 7 over inside, and I'll find 2 times sine pi by 7 times cos pi by 7, which is basically sine of 2 pi by 7, and this would become 2 times sine of 2 pi by 7 times cos of pi by 2 pi by 7 upon, and I'll rewrite this sine of 3 pi by 7 as sine of 4 pi by 7, again using the formula which is sine of theta equal to sine of pi minus theta, and this minus 2 would remain the same, thus making my entire thing. Again, I'll use the uh, double angle formula over here for sine, which is sine 2 theta equal to 2 sine theta cos theta, and this is sine of 4 pi by 7 upon sine of 4 pi by 7 minus 2, which is 1 minus 2 is minus 1. We were asked to find the mod of the entire thing, so we were asked to find mod of this thing, and hence the mod of this thing would be minus 1 mod equal to final answer, which is basically 1. Hence our final answer would be 1 for part A, which is option S. Second part of the problem, we have been given A plus B plus C equal to pi, and cos A equal to cos B times cos C. Then tan B times tan C is equal to what? So in the B part, we have been given A plus B plus C is pi, cos of A is equal to cos B times cos C, and we have to find tan B times tan C. So I'll be listing out the key concepts, and basically we are going to be using trigonometric identities and some special identities for specific angles. Trigonometric, rather, properties trig ratios, at specific angles. So the trigonometric identity I'm going to use over here is cos of a plus b is equal to cos a cos b minus sin a times sin b. That's it. And the properties of trigonometric ratio I'm going to use over here is cos of pi minus theta. Theta must be in radian or some angle suitably is equal to minus cos of theta. Alright. So we are given that cos A equal to cos B times cos C. So cos A equal to cos B times cos C. And as we are given A plus B plus C equal to pi, I can say that B plus A is equal to pi minus B plus C. This is an of course thing to do. And I'll just replace this A in our above equation so as to obtain cos of pi minus B plus C is equal to cos B times cos C. And we already know that cos of pi minus theta is minus cos of theta. Theta was B plus C is equal to cos B times cos C. So this cos of B plus C, I'll split it using the identity of cos A plus cos of A plus B, which is would make this as cos B times cos C minus sin B times sin C. This would be cos B times cos C. The RHS would remain same. और ये बन जाएगा minus cos B times cos C plus sin B times sin C is equal to twice of, or rather cos B times cos C, which makes the equation to be sin B times sin C equal to twice of cos B times cos C. मैं ये cos B times cos C जो LHS पे उसको मैं RHS में लेकर आ गया, तो ये बन जाएगा 2 टाइम्स cos B times cos C. और अब मैं दोनों साइड को cos B times cos C से डिवाइड कर दूंगा तो मुझे मिलेगा sin B times sin C अपॉन cos B times cos C, और RHS में डिवाइड करने पे तो सिंपली 2 मिलेगा. अब मुझे पता है कि sin B अपॉन cos B tan B होता है और sin C upon tan cos C tan C होता है. Hence I found the value of tan B times tan C to be 2. Which is option R in our column 2. Moving on to the third part, is given to be 4 times of cos 20 degree plus 8 times of cos of 70 degree, that is sine of 70 degree, times sine of 50 degree times sine of 10 degree upon sine square 80 degree. I have to find the value of this expression. So I'll be using some identities. The first identity that I'm going to use over here is sine of theta times sine of 60 minus theta times sine of 60 plus theta is 1 upon 4 times sine of 3 theta. The second identity that I'm going to use over here is cos of theta is equal to sine of 90 minus theta. Third identity that you are going to need is sine of 30 degrees is equal to half. Alright. That you are going to need is cos of 2 theta is equal to 2 times cos square theta minus 1. Alright, we'll be using these four main identities to solve this problem. So the expression we have been asked to evaluate is 4 times cos of 20 degree plus 8 times cos of rather sine of 70 degree times sine of 50 degree times sine of 10 degree upon sine square 80 degrees. Now we already know that sine 70 times sine 50 times sine 10 represent our identity sine theta times sine of 60 minus theta times sine of 60 plus theta, and where theta is assumed to be 10 degrees, and hence we'll have this as 4 times cos of 20 degree plus this entire expression would be rewritten as 8 times 1 upon 4 times of sine of theta would be sine 30 degree upon sine square 80 degrees. This is written to be 4 times cos of 20 degree plus 8 times 1 by 4 is 2, and sine of 30 degree is also 1 by 2, and denominator सेम ही रहेगा साइन स्क्वायर 80 डिग्रीज. एक्सप्रेशन है वो बन जाएगा 4 टाइम्स cos of 20 degrees minus 1 upon sin square 80 डिग्री. अब मैं sin square 80 डिग्रीज को देख सकता हूँ क्योंकि sin 80 डिग्री होता है 1 माइनस cos of rather cos of 90 minus 80 degrees because of the identity that sin theta is equal to cos of 90 minus theta. So using this identity I have got sin of 80 degrees is equal to cos of 10 degrees, and sin square 80 degree would be cos square 10 degrees, and hence my expression would be 4 times cos of 20 degrees minus 1 upon cos square 10 degrees. I'll rewrite this cos of 20 degrees using the double angular formula as cos of 2 theta is 2 times cos square theta minus 1. So I'll write this as 4 times 2 sin cos square 10 degrees minus 1 upon cos square 10 degrees, which is 4 times. Sorry, this already had. Sorry, this is minus 1, and the last one will be plus 1. This is 4 times 2 cos square theta 10 degrees, cos square 10 degrees upon cos square 10 degrees. Again, we'll just cancel these two off and we'll obtain our answer to be 8, which is answer to the part C. Part C will have the answer Q. Problem. We have to evaluate maximum value of 12 sin theta minus 9 sin square theta. So the one way and the best way to evaluate maximum or minimum of any equation is to differentiate it. So the concept involved over here will be differentiation. Key concept I'm going to use over here is differentiation. And how do you differentiate this? So we have d of sine theta upon d theta to be cos theta, and d of sine square theta upon d theta comes out to be 2 times sine theta times cos theta. Using this, what we need to do is we need to differentiate this entire equation to 0 and equate it to 0. So we have d of 12 sine theta minus 9 sine square theta to d theta should be 0, and the theta at which this happens would give us would be the value of theta where we'll obtain the maximum value of this expression. So we have got this done to be 12 times sine d of sine theta upon d theta to be cos theta minus 9 times sine square theta d of sine square theta d theta, which is 9 times of 2 sine theta d theta sine theta cos theta, sorry, and this should be 0. Hence we want 12 times cos theta minus 18 times sine theta cos theta to be 0. Now what we'll do is we'll take this 18 times sine theta cos theta on the RHS. That's to obtain 12 times cos theta is equal to 18 times sine theta cos theta. Now we have 6 times cos theta common on both LHS and RHS. Note that if cos theta is not equal to 0, we can just eliminate them off. So we'll have an additional case that cos theta is 0. And in that case, we'll try to evaluate our maximum value or rather expression value and see which is higher. So for now, I'll just eliminate 6 times cos theta from both the sides. So as to obtain 2 is equal to 3 times sine theta, thus giving me 2 upon 3 equal to sine theta. Also, for the case that cos theta was 0, the sine theta would come out to be 1. Now, I'll be using two things. Case 1 would be sine theta is equal to 1. Hence, our expression which is 12 times sin theta minus 9 sin square theta, would become 12 times 1 minus 9 times 1 square, which is 12 minus 9 is says 3. This is the expression value just in the case that sin theta is equal to 1. Case 2 would be sin theta is equal to 2 upon 3, and hence our value in that case would be 12 times of 2 upon 3 minus 9 times of 2 upon 3 whole square, which is 12 times of 2 upon 3 is 8 minus 9 times of 2 upon 3 square would be 4 upon 9, which is basically 4. Hence, we'll have our equation to be 4. Hence, in the case 2, we have a higher value, which is 4. Hence, our maximum value of the expression 12 sin theta minus 9 sin square theta would be 4. I hope you all understood it well, which is the option 4 is option P in the column 2. I hope you all understood it well, and best of luck.